So, very good afternoon, dear students. Today we are going to continue our previous topic, that is two-port networks. In the last two classes, we have talked about admittance parameters and impedance parameters. That is your Y parameters and Z parameters. And in the last class, at the end of the class, I told you that the next important parameter in your two-port network is H parameter, that is known as hybrid parameter. So today's class will be dedicated to the topic H parameters. And my dear students, let me tell you, being an electronics engineer, we must be aware of H parameters, because these H parameters will be helping us in analyzing bipolar junction transistors. You all know that BJT is the base of our electronic subject. So in analog electronic subjects also you will encounter H parameters. So that's why developing the concept of H parameters is very, very important, so that you can analyze or you can represent your transistors using H parameters. So here we continue further. So H parameters means hybrid parameters. So students, if you remember, we have talked about admittance parameters, that is Y parameter, where all the four parameters, they were representing admittance. Okay. Similarly, in the impedance parameters, all the four parameters, they were representing impedance. Okay. Whereas in case of hybrid parameters, we have, you can say, hybrid quantities, or you can say different quantities. So H parameters is a set of heterogeneous quantities. That's why we call it as hybrid parameters. Fine. This is one thing that you need to understand here. So let us now define H parameters equations. So these are the two equations. So here also you can very clearly see that on the left hand side we have V1 and I2. Okay, V1 is the voltage at the input port and I2 is the current at the output port. Whereas in case of your Y parameters, both these values were I1 and I2. Whereas in case of Z parameters, these were V1 and V2. And in fact, in H parameters, we have V1 and I2. Similarly, here also you can see that in the equation corresponding to V1, we have I1 and V2. Similarly, here also I1 and V2, not I1, I2 and V1, V2 as we encountered in case of Y parameter and your Z parameter. Fine. So equation for H parameter is V1 equal to H11 I1 plus H12 V2. Second is I2 is equal to H21 I1 plus H22 V2. So the same kind of representation here also has been followed. So if we represent in the form of matrices, this is the representation V1 I2. This is your column matrix equals to H. This is your H parameter matrix. And here we have I1 V2. And you can easily make out that what is the value of H. H is a matrix where 2 by 2 matrix, where you will be representing H is equal to H11, then your H12, then you will having H21 and H22. Okay, so this is your the way we represent your H matrix. Okay, you have already understood this thing in the previous classes also. Now let us define the four parameters. First is your H11. If we want to find out H11 here, we need to make V2 as 0. Okay, so V2 0 means we are short circuiting our output port. Fine. So that's why we call it as short circuit. And since it is the ratio of V1 upon I1, which is nothing but input impedance, so that's why H11 is nothing but short circuit input impedance. I hope everything is clear. Now let us talk about H22. Okay, so H22, in case of H22, If we want to extract H22, we need to cancel out I1. That means we need to make I1 equal to 0. So I1 equal to 0 means your input port is open. So that means we call it as open circuit. And I2 upon V2, it is nothing but the admittance. And admittance involving only the output port values. So that's why we call it as output admittance. So H11 is nothing but short circuit input impedance, and H22 is nothing but your open circuit output admittance. Okay. Now let us move to H12. What is H12? So here, if you see H12, H12 is nothing but we have to make I1 0. Okay. So H12 will be V2, V1 upon V2. This is H12 is equal to V1 upon V2, given that I1 is 0. Since I1 is 0, we call it as open circuit. Okay. And since it is from 1 to 2, we call it as reverse, as we discussed in the previous classes. And since it is the ratio of the two voltages, that is V1 upon V2, we call it as voltage gain. Why are we calling it reverse voltage gain? Because it is input voltage upon output voltage. Normally, the gain equation we define like this, that your output voltage upon input voltage. This is how we define our voltage gain. Now, since here we are defining it as V1 upon V2, that's why we call it as reverse voltage gain. Fine. So that is your third parameter, H12 open circuit reverse voltage gain. Now let us see the last parameters, that is H21. So this is your H21. Fine. So if we want to find out H21, then we need to make V2 0. So V2 0 means it is short circuit, and H21 will be I2 upon I1, which is nothing but current gain, and current gain in the forward direction. So we call it as forward current gain. So students, you can see here that H parameter is, you can say, a combination of four kind of quantities. One is your input impedance, another is output admittance, third one is forward current gain, and the fourth one is reverse voltage gain. So uh, the two quantities, that is your current gain and voltage gain, you have encountered for the first time in these two parameters. So all the four parameters, H parameters, they are representing four different quantities. So that's why we call them as your hybrid parameters. Okay. And if you talk with respect to electronic circuitry, then you can also see to it that your input impedance, output admittance or impedance, or current gain or voltage gain, they are of prime importance. Okay. So that's why H parameter is also very, very important to understand. Now let us move forward. So as I told you that the H parameters, they represent, okay. So as I told you that these H parameters, they represent an impedance, okay, admittance, voltage gain, current gain. That's why they are called as hybrid parameters. Okay. And another important thing is, though we have represented H parameters in the form of H11, H12, 21, 22, this notation is suitable for matrix representation. In electronics, you will come across these parameters with some different names or different notations. Okay. So like HI, HR, HF, and HO. If you remember, what was H11? H11 was input impedance. So I means input. So H11 is HI. H22, we talked about H22 as output admittance. So it was output. So that's why we have HO. This is your output admittance, which is equivalent to H22. Okay. Then H12, this was our reverse voltage gain. So this is our HR. Okay. And H21, this was our forward current gain. Okay. I hope I'm repeating the correct terminology. So H21 is your forward current gain. So that's why your H21 is nothing but your HF. Okay. So more precisely, we can say that H11, it is your HI. Okay. H22 is nothing but H0. Okay. HO. H21 is nothing but HF, that is your forward current gain, and H12 is nothing but your HR. So this is how you have to correlate your H parameters with the H parameters used to represent our bipolar junction transistor. Okay. So after discussing this, our next job is to try some simple numericals so that we are able to practice uh, how to obtain H parameters for a given network. So let us do that as we have done for our Y parameters and Z parameters also. And this network is very straightforward. I don't think it will take much time. So I'll hurriedly try to find out all the parameters. So I have again reproduced the definitions of all H parameters. So we will use these definitions and find out the value of all the H parameters. So first let us start with H11. As I told you earlier also, H11 is nothing but input impedance, which is nothing but V1 upon I1. We have to make V2 0. So V2 0 means you have to short this. Once you short this, then 6 ohm and 4 ohm, they will become in parallel. And the parallel combination of these two, it will be in series with 1 ohm. So I told you earlier also that input impedance is nothing but the equivalent impedance or the resistance that you look into from the input side. So if you obtain that, H11 will come out to be your 1 ohm resistance in series with your 4 ohm and 6 ohm resistance, which is in parallel. Okay. So if you solve this, this indicates the parallel combination. Okay. So if you solve this, what do you get? 6 parallel with 4, it gives you 2.4 plus 1, that is your 3.4 ohms. So this is the straightforward value of H11, which I also shown in the form of matrix here. Okay. So this is our H11. Now let us move to another simple to obtain parameter, that is your H22. So H22 is nothing but your output admittance. Fine. So output admittance is nothing but, admittance is the reverse of impedance, and impedance here is only the resistances because there is no other component. So you can say that it is reverse of 1 by R22. So let us now find out R22, which is nothing but the equivalent resistance which you look from the output side, that is your R22. So for this we have to make I1 0. So if you make I1 0, it means this will be open circuit. Okay. So open circuit means this resistance will no longer be present in the circuit. So we need to find R2 upon V2, but before that we need to find R22, which is nothing but V2 upon I2. And if you apply KVL here, so it is nothing but the equivalent resistance is the series of 6 and 4, that is your 10 ohm. It gives us 1 by 10. And the inverse of resistance is admittance. Okay. And the unit of admittance is Siemens. So this gives us answer 0.1 S. Okay. This is what you have here in the answer. So we have obtained two parameters, H11 and H22. Now let us move forward. Now we will find out H21. Let us do this. Okay. So in order to obtain H21, we have to make V2 0. Okay. Means you short this. So if you look at the circuit carefully, what we need to find out? We need to find out the relationship between I1 and I2. Okay. This point is short. we know that the current in this branch is how much? I2. If you see here that I1 is moving in this branch, and once it comes across this junction, this I1 will be divided. So in a way you can say that I2 is a component of I1, or you can say current has been divided. Okay, but there is one change here, change in the sense that when I1 will be entering in this node, then the direction of the component will be towards right hand side, whereas the direction of I2 is directed inward. So I should indicate this arrow with minus of I2 instead of I2, because I am reversing the direction. Okay, so now I can simply apply current division rule. So according to this, minus of I2 is nothing but the current which is present across 6 ohm resistance. Okay, so you know the current divider rule. Current will be dividing between 4 ohm and 6 ohm, so we will have 4 in the numerator. In the denominator we have 4 plus 6, that is 10, and the total current is nothing but your I1. Okay, and what we want? Ratio of I2 upon I1. So ratio of I2 upon I1, that is your H21, its value will be how much? Minus sign you can take towards right hand side. So your H21 will come out to be 0.4, and there will be no unit because it is a current gain. So H21 is minus of 0.4. So this is what you have got here. I think this thing is clear to all of you. Fine. Now let us calculate H12. This is our H12. H12 is nothing but the voltage gain. So I1 is 0. That means no current through this resistance. You can assume this resistance is no longer existent. That means this voltage V1, there is no drop across 1 ohm, and this V1 is appearing across 4 ohm only due to this condition. Now you see here, you apply now the voltage divider rule, that this voltage V2 is divided into voltage across 6 ohm and voltage across 4 ohm. And we are interested in voltage across 4 ohm because that is V1. So by applying voltage divider rule, we can simply say V1 is equal to voltage across 4 ohm, that is 4 ohm first, then total resistance, that is 4 plus 6, that is 10, and total voltage is how much? V2. You take V2 towards left hand side, and V1 by V2 comes out to be equal to your H12, which is nothing but 0.4. And this is also voltage gain, so that's why there will be no unit, and H12 is nothing but your 0.4. Okay, so with this we are able to find out all the 4 H parameters. So I hope all of you are clear with these parameters. So dear students, after discussing one numerical problem related to H parameters, we will now take up 2 more problems and try to find out the H parameters for these networks as well. So these are very simple networks. Once you are accustomed to the usage of H parameters, then it is a simple child's job to find out the values. You need not in fact carry out calculation. You can see the circuit and write the answers directly. We'll try to do that. So first let us consider network labeled as A, and first let us find out H11. So H11 we have already defined. It is your input impedance. Input impedance means the equivalent resistance looked into from input side. V2 is 0. That means this is short. This is short means this 40 ohm resistance will no longer be counted because of short in parallel. So you are left with only 20 ohm resistance. That means your H11 is nothing but 20 ohms. See how simple it is. Now let us find out H22. H22, as I told you, is your output admittance. Okay, so output admittance is nothing but the inverse of output impedance or output equivalent resistance, that is 1 by R22. So R22 will be equivalent resistance looked into from the output port. So for this I1 is 0. So I1 is 0 means this resistance, there will be no voltage drop here. Okay. So what we are left with? We are left with, you have I2 directed inwards from here. So I2 will be going through this 40 ohm resistance only. So I2 V2 will be nothing but your 1 by 40, or you can say R22 will be nothing but 40 ohms, and this comes out to be how much? 1 by 40. Okay. So 1 by 40 is nothing but, if you solve it, you'll be getting 25 millisiemens. So ms, it is not millisecond, it is Siemens, millisiemens. So this is what you get as H22. Fine. So after this, now we will try to find out H21. So H21 is nothing but the ratio of the two currents I2 upon I1, and V2 is made 0. So let us find out H21. So V2 is 0 means you have to short this. Okay. So here you have I2. Okay. Now you see this is short. This resistance is no longer in the picture. I1 is coming from that side. Okay. So it means you apply KCL here. That is I1 plus I2 equal to 0 and I1 equal to minus I2. And if you find out the ratio of I2 upon I1, which is nothing but minus 1. So H21 is nothing but minus 1. See, this is what has been represented here. Very simple. Fine. Now let us find out H12. So H12 is nothing but the ratio of the two voltages V1 by V2, and I1 is 0. Okay. So your I1 is 0. That means this resistance is no longer in the picture. Okay. Your I2 is there in this branch. Fine. This V1, there is no drop across 20 ohm. So it means this V1 will be represented across 40 ohm. V2 is also present across 40 ohm. So it means V1 equals to V2. That means the ratio of V1 and V2 will be nothing but 1. So that's why your H12 is equal to 1. Okay. Because your V1 is equal to V2. This is what has been represented here as H12. So very simple, students. So if you proceed systematically, it is very, very simple job to find out the parameters, and that is the beauty of using two-port network parameters, that once you are available with your input voltage, input current, output voltage, output current, your network can be represented like a black box using your two-port network parameters. So now let us move to your example number B. So here we will again find out these H parameters. So first, let us again discuss H11, which is nothing but your input impedance, which will be equivalent resistance represented from input port. So here you have I1. Okay. So here you have I2, and your V2 is 0. It means this is short. This is short. It means 40 ohm and 10 ohm resistances, they will be in parallel. Okay, so equivalent resistance will be 40 into 10 divided by your 50. So 40 into 10 is nothing but your 400 divided by 50, which is nothing but your H11 comes out to be 8 ohms. And this is the answer. Now let us find out H22. H22 is nothing but, as I told you, the reverse of the output equivalent resistance. Okay, so let us now find out that. So if we do that, the equivalent resistance for this case will be how much? V2, I2, and your I1 is 0. It means no current here. So it means all the current is passing through this. That means the equivalent resistance is 10 plus 40, 50 ohm. So H22 will be 1 by 50. And if you solve 1 by 50, what do you get? You get 20 millisiemens. Very simple. Or milli ohm inverse. So this is our H22. Fine. Now let us find out the remaining two parameters. That is H21, where V2 is 0, means we short this. Okay. H21. So this is our I1 and this is our I2. So as I told you in the previous example also, the direction of I2 will be taken in actuality as reverse one, that is minus of I2. And this minus of I2 is a component of this I1. Okay. So you apply current divider rule. According to that, minus of I2 is nothing but your current across 40 ohm resistance. 40 will be in the numerator. In the denominator, 40 plus 10, that is your 50. Okay. And into the total current, which is nothing but I1. So this comes out to be 0.8 and minus sign is there. So your H21 is nothing but minus of 0.8. And this is what is being given here, H21. Okay. Now let us find out H12. So H12 will be the ratio of the voltages. I1 is 0. I1 0 means no current here. Okay, it means this V1 is present across this resistance, 40 ohm resistance. So this V1 is nothing but a component of V2. So you apply voltage divider rule, that is your V1 is equal to voltage across 40 ohm. So it means it will be 40 divided by total resistances, that is your 50, into total voltage is V2. And the ratio of V1 by V2 comes out to be how much? Straightforward 0.8. So H12 is nothing but 0.8. Fine. So this is how we obtain the last parameter for this network, that is your 0.8. So students, if you are comfortable with the techniques, circuit analysis techniques that we have discussed till now, if you are well practiced with those techniques, then it will be very simple job to obtain these network parameters, be it your impedance or admittance or your H parameters. So dear students, after discussing three numericals on the calculation of H parameters, now I am giving you one homework where we are given with H parameters. So this is H parameter matrix, and for these given H parameters, you have to calculate Y parameters and your Z parameters. Okay. So for given H parameters, you have to calculate Y parameters and Z parameters. So you have all the equations with you. So this is the equation for H parameters. This is the equation for Y parameters that we have discussed. This is the equation for your Z parameters. So what you have to do, you have to basically combine these equations together and find out the value of Y. Similarly, you have to combine this Z parameter along with this your H parameter, and then you have to calculate the value of your Z parameters. Okay. So this is your homework. I will share this question on online classroom also. And before the start of tomorrow's class, I need everybody's solution to this question on online classroom itself. Okay, so this is a single question that I have given you as an assignment, and you have to complete it before the start of tomorrow's class. Okay, now let us move forward. So as I told you in the beginning of the class, that why H parameters are so important, because uh, the bipolar junction transistor that you have studied in your analog electronics, its equivalent circuit can be represented in terms of H parameters very easily. Okay, so right now you don't worry about transistor equivalent circuit. In this slide, what I'm explaining, I'm simply explaining the representation of these H parameters equation into some equivalent circuit. So if you look at this circuit carefully, it is very, very simple representation. Now let us see. We have V1, this is V1, this is our KVL equation. Okay, so V1 is equal to H11 into I1. So since I1 is the current, what will be H11? It will be impedance, or you can say input resistance. So V11, if you apply KVL here, so then what you will have, V1 equal to H11 ohm into I1. Okay, and if you come down, this is nothing but, this is a voltage source. Okay, this voltage source, its value has been shown as H12V2. Okay, and this voltage source has been represented in the form of a diamond. It means this is a dependent voltage source. So this voltage source is dependent on the output voltage V2. Okay, so this is your representation of your equation number 1. So since it is V1, this is also a voltage, this is also a voltage. So V1 is equal to H11, current is passing through this I1 current, plus this dependent voltage source whose value is H12 into V2. Okay, now this is your input part. Now let us move to output part, which is represented in terms of I2. I2 is a current. So it means these two terms must also conform to the current dimensions. Okay, so what we have, this is our I2. Fine. So this I2 will be divided into this branch and this branch. Okay, now if we want to find out current across this, how much will be the current across this one? So current across this will be the voltage across this branch, which is nothing but V2. Okay, V2 divided by some say equivalent resistance R, V2 by R. Okay, and 1 by R is nothing but your admittance. Okay, and that admittance has been represented by H22. Okay, so this will give us V2 multiplied with H22. This is what is there in the equation. So this is V2 into H22. So V2 is the voltage, H22 it is the ohm inverse, that is Siemens. So this resistance is H22 Siemens, which is nothing but admittance. And what is this? This is a dependent current source. Okay, so this current source is having the value H21 I1, and it is dependent on I1, that is the current present in the input circuit. So I hope this representation of your H parameter equations in the equivalent circuit is shown like this. And students, in the next slide we will see that this is nothing but it is the equivalent circuit of the transistor. Okay, you all know that how does a transistor work. I'll advise you people to again read the working of bipolar junction transistor and try to correlate that working with the equivalent circuit that we have shown here. You all know that there are 3 terminals in the transistor, that is your emitter, base and collector, and how does it work. So this is the equivalent circuit for your H parameters representation. Now let us move forward. So this is your transistor, which has three terminals. One is your base, another is your collector, and third one is your emitter. Okay, so your BJT parameters, your transistor parameters, they are uh, generally quoted in terms of H parameters. Okay, and we know that your transistor can be connected in different configurations. So these H parameters are measured when your emitter terminal is grounded, means common emitter configuration. So means we will be grounding the common emitter, and in the input part we will have base emitter junction, and in the output part we will have collector emitter junction. So our input will be emitter base or base emitter junction, and output will be collector emitter. Okay, and let me tell you students, up to this slide or up to the point where we have started correlating H parameters with your BJT, before that we were considering our circuit as a linear circuit. If you remember, from the very beginning we are assuming that our circuit is a linear circuit. Our circuit components are nothing but linear components. You all know that transistor is a non-linear device. Okay, so that's why earlier what was happening, if we were able to find H parameters or Z parameters or Y parameters, those H parameters, Y parameters, Z parameters will applicable for all possible values of currents and voltage, because our circuit was linear. So if your input current, input voltage changes, your output voltage, output current, it used to change in a linear fashion corresponding to your input values. Whereas since your transistor is a non-linear device, if your input voltage, input current changes, then your output current, output voltage may not behave in the same fashion. Added to this, your BJT is also a temperature dependent device. If you do not change current and voltage, but your temperature changes, because of that also your current and voltage value will change. So that's why it is very important to note here that if you want to apply H parameters to the transistors, these H parameters must be quoted at a specific value of collector current and collector emitter voltage. Okay, so we will be specifying H parameters at a given value of collector current and your VCE, collector emitter voltage, because if these changes, the value of H parameter is bound to change, because your BJT is a non-linear device. So that's why whenever you come across H parameters with regard to bipolar junction transistor, you will always notice that those values are for a given set of current and voltage parameters. Please mind this thing. Apart from that, if you have ACH parameters, ACH parameters means when your sources, independent sources, they are AC, or DCH parameters means when your independent sources in the circuit, they are DC. Those are also different in values, because your non-linear device will behave differently if you apply AC or if you apply DC. So students, all these points are very, very important if you want to correlate your H parameters with your BJT parameters, bipolar junction transistor. And I will also tell you one thing, that you look for some data sheets for any transistor, either PNP or NPN. There you will come across the values of H parameters at a given value of collector current and collector emitter voltage. Okay, so now let us move forward. See, for your reference, I have included one table here. So if you look at the data sheet of any transistor, so as I told you, these are the values of those H parameters or transistor parameters. These values are defined at IC equal to 1 milliampere, VC is equal to 10 volt, and even frequency has also been specified, that is equal to 1 kilohertz. Okay, because the response of your transistor will also depend on the frequency. So C, the parameter of transistor is input impedance. Input impedance is nothing but H11. Okay, its value is 1 to 10 kilo ohm. Fine. Then H voltage feedback ratio, that is H12, that is your voltage gain. Okay, so here it is represented as HIE. E means emitter. Okay, common emitter configuration. So HIE is uh, input impedance for common emitter. HRE is your voltage gain, reverse voltage gain. HFE is your current gain. Then HOE is your output admittance. So see, the current gain is 100 to 400. Then your output admittance, it is 1 to 40. This is micro mohs, inverse ohm. Okay, and there are no units for that. So this is just to give you an idea that how we are representing or characterizing our transistor in terms of H parameters. So in the data sheet, you will find these parameters: HI, HR, HFE, HOE, or you will come across these names: input impedance, small signal current gain, voltage feedback ratio, output admittance. So these are nothing but, you can say, correlated directly with each other. Okay, so if you correlate these H parameters with BJT, then you can understand the significance of your H parameters in your analog electronics. I hope this thing is clear to everybody. So students, after covering H parameters in detail and its correlation with the bipolar junction transistor, now we move to transmission parameters, that is your ABCD parameters or T parameters, one and the same thing. And we call them as transmission parameters because they are used for the networks where the energy or the signal transmission is directed from input to output. You must have heard of the term transmission lines. So that's why these transmission parameters are named as transmission parameters, because they can be used there. Okay, so since from the name itself it is clear transmission, so transmission will be in one direction, you can say from input to output. So it means the direction of I1 is confirming from input to output, but the direction of I2, if you look at the previous slide, was directed from output to input, but actually it should be from input to output. So that's why in case of transmission parameters, the direction of I2 has been specified outside, and in order to confirm with previous notation, I2 will be taken as negative. So these are the defining equations for your transmission parameters. So here you can see that your wherever I2 is coming, it is your negative sign. So the first equation is V1 is equal to T11 V2 minus T12 I2. Okay, and your second equation is I1 is equal to T21 V2 minus T22 I2. So here, since we are calling them as transmission parameters, it means on the left hand side we will have the input port, and on the right hand side we will have the output port, and in the output port the direction of the current will be reversed, that is minus of I2. So this way you can correlate. One of the student was asking that how are we defining these equation. So just by this analogy we can easily define these equation. Since it is a transmission parameter, we need to go from input to output, or we need to transmit from input to output. So at the input we will have V1 I1, at the output we will have V2 I2, and since we are transmitting, the direction of current is reverse, so that's why it has been taken as minus I2, and this is T is the transmission matrix, transmission parameter matrix, which is defined as T11, T12, T21, T2, T2, which is equal to A, B, C, D. So these transmission parameters are also called as A, B, C, D parameters. So rest of the things are very clear. the way we have obtained the values of z parameters, y parameters, h parameters, in the same way we will find out the values of a, b, c, d. The value of a will be v1 upon v2, i2 is 0. The value of b will be v1 upon minus i2, given that v2 equal to 0. Similarly, the value of c and d. And I don't think there is any need of further explanation in representing the value of transmission parameters. So students, with this, our discussion on all the 4 parameters is complete. I make an appeal that you try to solve maximum numericals related to the calculation of all these 4 parameters, and try to practice as much as you can. One homework assignment I have given you, that you submit before the start of tomorrow's class, and then we will continue with next topic, where we will try to obtain the relationship between different parameters. Like we will express your z parameters in terms of other 3 parameters. Similarly, we will express y parameters in terms of other 3 parameters, and so on. So that relationship among different parameters is also important from numerical solution point of view. So with this, we stop here, and we will continue in the next class.